Then we have some DNS service providers. So you might say, this DNSSEC stuff is so complicated, I just want to give it to somebody else and have them worry about it. And you can do that. And there are companies that you can outsource your DNS to, and they will support DNSSEC. Now, if your organization does not want to outsource your DNS, but does want to support DNSSEC, that may not be a good solution for you, but it's an option. And then finally, there is a category of products called, I call them signing appliances. So these are products that are designed to fit into your current DNS infrastructure. Typically, you are either running Bind or you're running Microsoft DNS, most typically. And they're designed to fit into that infrastructure and deploy DNSSEC without you having to change Bind or Microsoft in order to do that. And I'll explain how that works. That is what Secure 64 does. We're in this last category. So for organizations that run their own DNS and want to continue to run their own DNS, this can be an attractive solution. Okay so far? So Secure 64 has a family of very secure DNS products, as you might imagine from our name. We have an authoritative server. We have a caching server, Resolver. And we have something we call our signing server. And from the charts and graphs we've put up earlier today, it's pretty obvious to understand what the functions of these three products are. One is authoritative, one is caching. The signing server will be a little bit clearer when I show you another picture about how that fits in. All of these products are built on an operating system that we have developed ourselves to be extremely secure. It takes advantage of some of the security capabilities found only in Itanium-based servers from HP, and it utilizes something called a TPM, or Trusted Platform Module. It's a chip inside the server that provides root trust and allows us to do things in software securely that is not possible with conventional open source operating systems like Linux or even proprietary one like Microsoft.
TPM is almost in every TPM, the Trusted Platform Module, is very popular. It's almost in every PC that you can buy.
Yes, yes. The difference is we're using the TPM in the HP server, and we're using the security capabilities of the Itanium microprocessor, which do not exist in x86. So my next slide I will explain some of the things that we do in the OS that are different. So when we deploy a server on the internet especially, we typically harden the server before we deploy it. And when we harden a server, it means we're doing three things. We are minimizing the number of user accounts on that server. We are eliminating any system functions that aren't necessary to reduce the attack footprint. And we're closing all unnecessary ports. So we're trying to minimize the attack surface on a traditional server. In our OS, we're doing the same three things, of course, as we deliver this we call it a software appliance. So we deliver the OS and the application as a unit. But we're going well beyond the traditional hardening approach. And we're able to do these things because of what the microprocessor and combined with the TPM chip allow us to do. This gets very, very technical. So I'll just try to give a few examples. We have a white paper written on this for those who might be interested in understanding more. For example, our software is always signed and encrypted, and it can only run on the machine that it was designed to be run on. So you download the software, and when the computer system boots, the server boots, the hardware checks the digital signatures of the firmware on the server. This firmware checks the digital signature of the next firmware before it's allowed to execute, and so on until we get to the loader. The loader checks the digital signature of the operating system before it's allowed to boot. It sounds familiar. It's a chain of trust, just like we talk about in DNSSEC. Chain of trust from the hardware all the way through the boot process to the loader, to the operating system, and finally to the DNS application. So there is not so if an attacker were to try to insert some malware onto the server, it would invalidate the digital signature and it wouldn't boot. The server would not allow that to occur because the digital signature would be invalid. We use also something called compartmentalized memory. So on the Itanium microprocessor, we can allocate memory and only allow essentially authorized applications to access that memory compartment. And this technology does not exist in x86. Cost the organization human resources to deploy and maintain DNSSEC using the tools that they had chosen. So they estimated it would take 1.5 additional staff people to maintain DNSSEC. Based on that, they decided to look for other solutions on the market. They chose Secure 64. It took about between 3 and 5 days for them to deploy Secure 64 into a pilot, which they ran for about 30 days. Well, they made sure that everything was working right, and at the end of 30 days, they put it into production. So they've been running in production for over a year. They haven't had a problem, an error of any kind that would cause the domains to go dark. And they did not have to add any staff in order to deploy DNSSEC. So I think it illustrates the trade-off, right? If your organization has the resources and has the time to learn about it, then open source tools or other solutions may be a workable solution for you. And then there's automated solutions that can take that cost away. So that's it. There is, for those of you who might want more information, of course we have quite a bit of information on our website, white papers, and so forth. If you search on YouTube for Secure 64, you will find some short videos that explain you're all experts now, so you don't need to understand how DNSSEC works, but there are some other videos that talk about options, deployment options, and also talk about the Signer product a little bit more. And of course, Elias is always available to answer any questions.
¿Comentarios? No. Muchas gracias.